or discussion about the development of minerals compared to plenty of minerals, variety of mineral species, and the abundance, physical and chemicals, characteristic of minerals, grain size, and morphology. First of all, what is nanominerals? Nano meaning which is clear, and mineral meaning inorganic compounds with geosources and elements that are the earth. So nanogeochemistry, a study of structures and crystal of minerals on chemical view. Nanominerals, science and research and study on minerals includes methodology, structure and crystal properties, and morphology and application. So nanomineralogy include nanomineral chemistry and mineralogy and geochemistry, in addition nanogeopolymer with nanocrystals. What about the minerals? A solid inorganic substance occurring in nature, definite chemical composition and crystalline structure, and the formation by inorganic geo and biological sources. About the distribution and occurrence, they are in the water, soil, air, and biological cells. And the mineral make up most of the earth and are important part of our everyday life. This picture shows example of natural minerals. About the classification of minerals are based on size, crystals for the nanostructure. There are more than 1,000 of minerals recognized, but only about 30 are most common. In this image shows natural process leading to formation of nanoparticles in the environment. A basic classification of minerals is native elements, for example, gold, oxides, for example, corundum, hydroxide, for example, goethite, and sulfide, for example, pyrite, and sulfate, for example, gypsum and barite. And the other minerals include carbonate, for example, calcite, phosphate, apatite, halite, for example, halite, and the silicate, the forms of orthosilicate, ring silicate, chain, and sheet. For example, moscovite, mica, and framework quartz, and feldspar, and zeolite. In this picture, you can see proposed reaction mechanism for the generation of silver nanoparticles in the natural environment, NOM. And about the methods for characterization, there are some methods, for example, optical microscopy with range identified micrometer, scanning tunneling microscope, STM, scanning electron microscopy, SM, and TM. And about the dimension structure, there are 3 dimensions, 3D, 2D, and 1D. For example, about the 3D, we can find inactivated carbon, colloidal particles, and nanoporous silica, nanocapsules, nanograins, nanoshells. And 2D dimension, there are some categories in nanorods, nanofilament, nanotubes, and nanowires, and then quantum wires. About the 1 dimension, there are disc plates, ultra-thin films, and superlattice quantum wells. But about the properties of the nanoparticles, we can consider on some view, for example, large surface area to volume ratio, we can see the atoms having different magnetic coupling with neighboring atom, different and magnetic properties. And then nanoparticles, for example, gold become ferromagnetic with interior solution. Magnetic, we can take the imaging and bioprocessing. And about the optical properties, the conduction bond and the HOMO and LOMO transmission between some levels in atomic echelons. And there are electrons occur between these 2 states by reflectance. About the difference in nanoparticles in dimension and physical properties such as color. For example, you can see gold nanoparticles in the different color and many different properties. For example, mineral in semiconductor and electronic properties, quantum mechanical effects, and optoelectronic effects. And also chemical composition, specific gravity, odor, hardness, and luster with difference in nanoparticles in dimension. But about the application of nanominerals, about the application in chemical products, consumer goods, transportation, electrical and electronics, energy, packaging, construction, healthcare, and I add to the next lecture presented by my colleague is about the application of one of the nanomaterials in industry, and we have many experience in electroplating wastewater and mining effluents for removal and destruction. And the other application of nano materials, for example, nanobentonite in plastics, nanoclay in polymers, and nano titanium dioxide in wear and corrosion, as the same of the before presentation, and nano calcite as a paint and pigments and polymers. But about the application and global marketing, for example, metal oxide, metals, and chemicals. The marketing global in the US and the UK, China, Brazil, and Africa, and Asia Pacific. Global nanomaterials market, we can see the increasing from 2014 to 2020. This chart is related to before. About the some methods for the identification and characterization of the nanominerals, a list of the physical properties, and their categories, about the metrics, and a list of chemicals and instruments. You can see the these categories in the diameter, volume, area, mass, surface charge, and the others. Due to the lack of time, for analysis and characterization nanoparticles, there are more methods, optical and wet chemical, the mechanicals, but the famous are AFM, BET, and DLS,